Okay, so those you have solved this equation, you know that this is a damping function, right? Y will be a damping function in with respect to time. But in this video we will write a Python code here. Okay, let me erase this thing. I will write the code from the beginning. So I will write a code here to solve this equation. Okay, and in some videos, in the next some of videos, I will solve many differential equations with code. So let's start. So first I have to rearrange this equation. Dy by dt is equal to minus 1 by tau y, and then I will write dy is equal to minus 1 by tau y dt. Okay, so dy is a small change of y, right? So we will need this. So what will we do in my code? In this code we will assume that tau is a constant. Let's say it's 5. Okay, and obviously we need an initial condition. That means when t is equal to 0, time is 0 in the stopwatch, y is equal to, let's say, 10. So this is our initial condition, and then we have to choose dt. Theoretically dt tends to 0, right? Infinitesimally small, but in my code I have to choose dt a small number, let's say 0.001. okay, now I need to write a for loop here. Let's say I want to okay, I will write a for loop here, and then in the code I will say what will we do now inside. So first I will write dy is equal to minus 1 by tau y dt. So dy is the small change of y, right? So initially y was 10, and after a small change y will be we will get a new y, and that will be y plus dy, and let this value inside y. That means we are updating y, right? We are getting a new change in y, and we are updating y, and let's see what happens in the code. Okay, so I need numpy. I will need numpy later, so I have to import numpy as np. Okay, let's write tau is a constant 5, and our initial condition y is equal to, let's say, 10. Okay, and dt is a small number, let's say 0.001. okay, now I will write a for loop here. So now I have to choose a time. So what will be our time? Let's say np dot arrange. Our time will be 0 to 5 seconds, and interval will be dt. So what this line will do, np dot arrange, what this line will do, np dot arrange 05 dt. This will make a numpy array like 0, then 0 plus dt, then 0 plus 2 dt, and it will goes on up to 5. That means 0 to 5, and the time interval is dt. Okay, so let's start. Now let's say for t in time. So what this line will do, it will pick specific t will be for t in time. That means t will be first 0, then 0 plus dt, then 0 plus 2 dt. okay, so inside for loop I have to write the small change of y, and that was what that was, minus 1 by tau y dt. okay, so minus 1 by tau into y into dt. okay, so now I have to update y. So update y, I have to write y plus dy. It's a new y, and put this thing in the y variable, and yes, our code is done. Okay, so our code is done. So to see the values of y in a plot, we need another module, import matplotlib dot pyplot, and name it as plt. Plt. okay, now we have time, right? We have a time array, but we don't have any y array, so make a new array here. Y is a blank. Okay, is a blank array, and now put the values of y inside this new array. So let's write yy dot append and put this here. Okay, now we need to plot these things. So plt dot plot at axis is time and y axis is yy, and then plt dot show. Okay, so let's see what happens. Let's run the code here. Okay, so I get a plot, but this is not a this is not look so good. So let's plt dot grid true, that I will have a grid here. Sorry, then I will have a grid in my plot. Okay, so I have a grid in my plot. Now let's increase the time. Instead of plotting from 0 to 5 seconds, let's increase it up to 25 seconds. Okay, so let's see what happens. Okay, so this graph looks perfect. Initially the value of y is 10, and you can see that it's a damping function. And okay, so thus you can solve the equation and find a graph of y.